Okay, so I hope that you watched the previous video on graphing constant angular motion, and now we're just going to take a look at the application of this in example 2. So we see a graph of a object that is changing in angle over time, and on the vertical axis we have this plotted. There's a typo here actually. That should be theta, and I think that should be in radians, not degrees. Okay, over time, right? And then we're asked to plot the graph of the angular velocity over time. So I hope that you recall that the slope of a angular position over time graph, so the slope, which is delta theta over delta t, represents the angular velocity. So we take the slope of this graph, let's take it, say, from, I don't know, from 3 seconds, I'm assuming that's 3 in here, to a magnitude of, I'm guessing that's about 6 pi. So the rise would be 6 pi, well, minus 0, let's say, divided by the run, which is 3 seconds. So this is going to be 2 pi rads per second. So this is basically from 0 to 3 seconds. So how does that show up on this graph? Well, assuming this is like 3 in here, then we're going to have a nice horizontal line, like maybe about here. And it's good because it's going at constant angular velocity. Then let's take a look from, say, 3 to, what is this? This looks like 5 seconds. So 3 to 5 seconds, that slope will be what? It is dropping by how much? Looks like it's going from 6 pi to 4 pi, so it's dropping by 2 pi. And it's doing that over 5 seconds minus 3 seconds, which is 2 seconds. So that looks like it's going to go at negative 2 pi rads per second. So that means my next line, if that's like, let's say 2 pi, and this is negative 2 pi, so this must be like around negative pi here. Okay, so our next line from 3 to 5 seconds, which is about here, is going to be a nice horizontal line again, but below the axis. Okay, and then lastly, from say 5 to 6 seconds, we can see that the slope of the graph is basically 0 because it's not changing, it's just a flat horizontal line. So that means in this graph here from the last second here, 5 to 6 is 0. Okay, some other cool questions that we could ask is, what do you think, how could we use this graph, let's say, to calculate the angular position? Think about that. Maybe pause the video and wonder. Okay? Hopefully you might be thinking that really it is essentially the area that is bound between the curve and the axis. So you would just simply, if I were to ask you to calculate the angular displacement, I would, calculate this area, which would be 2 pi times, say, 3. That's 6 pi rads. And then I would multiply this, it would be like 2 times pi, so it would be negative 2 pi. So the first bit would be 6 pi, and the second bit would be 2 pi, so that would be an angular displacement 2 pi, 4 pi actually. So I didn't ask that question, but it's good to know that. All right, that's going a little bit further. Okay, that's it for this example number 2.